Okay, right now in question C, they say that calculate the value of theta if theta is less than 90 degrees. So our theta has to be less than 90 degrees. So I guess that in this triangle ADBC, angle BDC has to be the biggest one, because already we know that angle DBC is 25 degrees. So that means if that angle C there, or that angle theta, is less than 90 degrees, that means that the biggest angle in this triangle, it has to be angle BDC or angle CDB. All right, I hope that you understand it, because it means that theta is going to be an acute angle. Seeing that also DBC is also an acute angle, it means that this one BDC is going to be an angle probably bigger than 90 degrees. All right, so let's do this. So we're now in triangle DBC. All right, now we know that in triangle DBC we have DBC, the angle, we have angle DBC being 25 degrees, and we also have that CDC, right? We also have that DC is equals to 6 units. And then another thing that we have is that BC is going to be equals to 2 times CP. And the reason for that is because of OP is perpendicular to BC. But to write it down, you're going to say that line from center perpendicular to chord. Alright, line from center perpendicular to chord. And then you're going to say 2 times CP, which is 6 units. That means that's going to be 12 units. Alright, now looking at that, can you see that we have a length, and we also have a length, and we have an angle there. Can you see that this length CD, it goes on with that angle there, and then that length there, it goes on with that angle BDC. All right, so we're going to try to find angle BDC. From there onwards, it will be possible for us to find angle theta or angle BCD. All right, now to do that, we're going to apply something called the sine rule. So we're going to see that sine of angle BDC is going to be, sine of angle BDC is going to be over BC. Then we're going to say equals to sine of angle DBC is going to be over DC. All right, and the reason for that, it's sine rule. And then we're going to say sine BDC over 12 equals to sine 25 degrees over 6. All right, then if we cross multiply, there is going to be 6 sine BDC, and then that would be 12 sine 25 degrees. Then we're going to divide both sides by 6. Then we're going to be left out with sine BDC, which is going to be 2 sine 25 degrees. Then BDC is going to be shift sine of 2 sine 25 degrees, right? And then if you do that in the calculator, so you're going to say shift of sine 2 sine 25. The answer that I get, it's 57.697286 27 degrees. Now to round off to 2 decimal places, my answer is basically just going to be 57.7 degrees. Now remember, from before I started out this question, we are told that theta has to be less than 90 degrees. So can you see that BTC, now that we calculated, it's actually less than 90 degrees. It means that now if we had to calculate theta, like minusing 180 minus 25 minus 57.7, that theta there is going to be bigger than 90 degree. But in this question, that's not what we're looking for, because I told you that if that angle theta is less than 90, it means that it's going to be an acute angle. Seeing that also DBC is also an acute angle, it means that the largest angle has to be angle BDC. Now in this case, can you see that we have it as 57.7, have it as 57.7 degrees. Now to make it bigger, we're gonna say that therefore angle BDC has to be 180 degrees minus 57.7 degrees, right? And if you do that, it's going to be 180 minus 57.7, which is going to give us 122.3 degrees. Now that's going to make sense, because now angle BTC is the largest angle, as I have said. Now from here onwards, using a different color, now I'm going to say that therefore theta is going to be equals to 180 minus BDC minus angle DBC. All right, and then I'm gonna say interior angles of a triangle. Interior angles of a triangle. Then I'm gonna say 180 minus 122.30 minus 25 degrees. If you put that in a calculator, so it's 180 minus 122.3 minus 25. The answer that you get there, it's going to be 32.7 degrees. And now that makes sense, because now our theta is less than 90 degrees. So if you didn't do this part here, so if you didn't do this part here, this one here, to show you, if you now just took that BDC, it's 57.7 degrees, you're gonna say that 180 minus 25 degrees minus 57.7, can you see that theta was going to be 97.3 degrees? And that's not what we're looking for in the question. So immediately in the paper you got 97.3 degrees. You were automatically wrong, because that theta, we are told that is less than 90 degrees. That answer is bigger than 90. So the only way was to actually make BDC a bigger angle by subtracting 180 with 57.7 to give us 122.3. Sort of like a logic that you had to apply so that you can get a smaller angle for theta. Okay.